All right, guys, so here is your video lesson on differential equations. So when you're given a differential equation, what it is an equation that's in terms of a derivative. You're given dy dx equals something. And what you need to do is go backwards to find the original function. So essentially what you need to do is just an antiderivative. And so I made this really simple one first for us to look at. It can get kind of complicated, and I'm going to give you some steps, but just to look at a really simple example. If this is your derivative, dy dx, and you want to go backwards and find the original function, you're just going to do an antiderivative. So for 4x, antiderivative would be 2x squared. For 3, it would be 3x. And then this is called an initial condition. And so we want, if you plug in 0, to end up with 5. So we would need to put a plus 5 at the end, so that if we plug in 0 for x, we get 5 as our result. And so that would be your solution to the differential equation. If you have an initial condition, this is called a particular solution. It's one answer. It is one particular solution for this piece of information, 0, 5. If you're not given an initial condition, then you're finding an infinite number of answers. You would put a plus c in there for the constant, and c can be anything, so it's the general solution. It's a representation of an infinite number of answers. So you're either finding one particular solution or an infinite number of solutions, just the general solution. So here are your steps. First, you're going to separate the variables. Anything with a y is going to go on the left. Anything with an x is going to go on the right. All right, and then you're going to do the antiderivative, so integrate. And make sure that you put a plus c. I make that its own special step because it's so important that I make it a step all by itself. So separate the variables, integrate, do the antiderivative, put plus c. Then if there is an initial condition, you're going to plug that in. If there's not, then you just skip that step and you get the general answer. So if you don't have an initial condition, just don't do that. And then last, you're going to solve for y, which, believe it or not, ends up being the toughest part. That's where all the algebra comes in, having to get y by itself. So sometimes that can get kind of messy and you just have to be careful and just rely on your algebra skills. And we are just going to practice a bunch of them. This is just kind of a cut and dry topic, right? So for number 2, we're going to multiply over the dx and then multiply over the 3y squared. For ones like this, you can even just think of it as cross multiplication. And we're going to end up with 3y squared dy. And then when we multiply the dx over, it's 1 dx. So that's separating the variables. And then you're going to do the antiderivative. I usually put this in here with a different color. It doesn't show up real great on the video, but I put that in there with a purple pen. Sometimes I think it's nice if you do that with a different color so that you can see that that's the next step you're doing. So the next thing we're going to do is the antiderivative. So for 3y squared, that would be y cubed. And then antiderivative of 1 would just be x, and then put plus c. Why didn't we put a plus c over here? You can if you want, but you would have plus a constant and plus a constant. And then if you subtracted that over and combined them together, a constant plus or minus a constant would just still be a constant. Like, it's still just c. So you can just put it at the end of everything. Now, this one didn't have an initial condition, so we're just finding the general solution. So we're going to skip this step and just solve for y. So to get y by itself, we would do the cube root. And so it's cube root of x plus c, and that is your answer. So again, remember, this is actually an infinite number of solutions because c could be any number. So it's the general solution. This one, we're going to get a specific solution. We have an initial condition. So again, this is an infinite number of answers. Here, we're going to get one specific answer. So we're going to multiply over the 4y, multiply over the dx. Or again, for this one, you can think of it as just cross multiplication. So we're going to get 4y dy equals 3x to the 5th plus 1 dx. And then do the antiderivative. So on the left side, that's going to give us 2y squared. Over here, this would be 1/6 x to the 6. but we have a 3 there, so it'd be 3/6, which would be 1/2. So 1/2 x to the 6th plus antiderivative of 1 would just be x, and then plus c at the end. Now we're going to plug in the initial conditions. So we're going to plug in 0 for x and -2 for y. So if we plug in 0 for all these x's, those are going to just be gone. This will just give us c on this side. Plugging in -2 for y, -2 squared would be 4 times 2 is 8. So we get that c is 8. Again, over here, we don't know what c is. It could be anything. For this problem, we know that c is 8. So we're going to go back a step, recopy this line exactly how it looks, except plug in the 8 for c. So we know that c is 8, just recopy that line, but plug in 8 for c. And now we're going to solve for y. So to get y by itself, we're going to divide over the 2. And you're best off just leaving everything alone for these. Like just divide over that 2, just all of that over 2. And then to get rid of the squared, you're going to square root. Now, usually with even roots, so square roots, 4th roots, 6th roots, all the even ones, you would need to put a plus and minus. This was an odd root, so we didn't need to worry about it there. But all the even ones, you would normally put a plus and a minus. And for the general solution, you would put a plus or minus. But since here we're finding one specific solution, you need to go with what the y value on your initial condition says. And since that is negative, we want the negative square root. So it's going to be negative square root of all of this. And that is your final answer. So again, for the even roots, you would do plus and minus if it's the general solution. If you want one particular solution, you need to decide, do I want the plus or do I want the minus? And in this case, our initial condition was negative, so we want the negative solution. The idea is if you plug in 0, you would get -2. All right, so trying the next one. Again, this is going to give us one particular solution since we have this initial condition. So we are going to divide over the y to the 4th. So when you divide that over, it would be y to the -4th dy. And then we're going to multiply over the dx. So what we're left with over here is 4x dx. So again, we divided over the y to the 4th. So since it's divided over, it would be 1 over y to the 4th. I just wrote it as y to the -4th. And then 4x dx on the other side. So antiderivative. So we're going to add 1 to the power. It would be y to the -3rd. And then we need a -1/3 out front. Over here, this will be 2x squared plus c. I'm going to go ahead and fix the negative exponent because we have to plug in this initial condition. And I think it's a lot easier to plug in if you don't have a negative exponent. So I'm going to bring that y to the 3rd down to the denominator. And now I'm going to plug in the initial condition. So we're going to plug in 0 for x. That would make all this go away. That's just going to give us c. -1 for y. So -1 cubed would be -1. Negatives are going to cancel. And so we get that c is 1/3. And so I'm going to recopy the previous line just exactly how it looks, except I'm going to put the 1/3 in for the constant. And then your last step is to solve for y. Again, lots of times that can be the trickiest part because you have to get the y variable alone, and it's oftentimes a lot of algebra. So I'm going to need to come over here for this. I'm running out of room at the bottom here. First, I'm going to multiply the y to the 3rd over to the other side. So if I multiply this over, I'm going to have -1/3 equals all of this times y cubed. So I just multiplied the y cubed to the other side. And then I'm going to divide all of this over to the other side. So I'm going to divide everything that's in the parentheses. So essentially, they just switch places. Oops. And then your last step to get y by itself would be to cube root. So you're going to have cube root of all of this. And again, that is one particular solution for this initial condition. All right, number 5. This one doesn't have a y in it at all, which is actually kind of nice. To separate the variables, all I need to do is multiply over the dx. So we're going to have dy, and sometimes it's nice if you put a 1 in front of that. 1 dy equals all of this dx, and then antiderivative. So what's nice about this is when you do the antiderivative of 1 dy, that's just y, and so you already have y by itself, which the goal is to get y by itself in the end, so that's kind of nice. All right, this is going to involve a u substitution. We're going to let u equal the denominator, the x cubed plus 4. du would be 3x squared dx. I need to change that 3 to a 5, so I'm going to adjust it with a 5/3. I ran out of room. Let me rewrite that. I'm so sorry. All right, so in place of the 5x squared dx, we're going to put 5/3 du. So 5/3 goes out front, du goes at the end. What's still there is 1 over u, and that antiderivative is ln of u, which is this x cubed plus 4 plus c. And then we're done. We don't have to worry about getting y by itself because y is already by itself. And we don't need to worry about figuring out what c is because we were not given an initial condition. So this is the general solution. Again, this is an infinite number of answers because c could be anything. All right, this one, again, there's no y in the problem, so we're just going to multiply over the dx. Again, sometimes I'll put a 1 in front of the dy. And then when you do the antiderivative, you're going to have y equals, which again is nice because the goal is to get y by itself. So antiderivative for cosine, you need a function that if you did the derivative, you would get cosine. That would be sine. And this would be another u substitution, which you can write out if you want. Let u equal 5x, derivative would be 5. We're going to adjust with a 1/5. So it'll be 1/5 sine of 5x plus c. And actually, that's all that there is to that one. I guess I just wanted to throw one with some trig in there. All right, this one, you'll see this sometimes, and this is really annoying to me. They write y prime instead of dy dx. If your first step is that you need to separate the variables, then you need to have a dy and a dx. So I'm just going to rewrite that y prime as dy dx. They both mean derivative, but you need it to be written this way so you can separate the variables. All right, so to separate, we're going to divide over this whole square root and then multiply over the dx. And again, that will leave dy by itself, which is nice because we'll end up with a y equals in the next step. And again, the goal is to get y by itself. All right, so this will give us y equals, this is again going to need a u substitution. U would be the part that's inside the square root. So du would be 2x dx, and we're going to adjust with a 1/2. So in place of the x dx, we're going to put 1/2 du. And what's still there is square root of u, but it's in the denominator. So it would be u to the negative 1/2. 1/2 because it's a square root and negative because it's in the denominator. All right, so that antiderivative, you would add 1 to the power. So negative 1/2 plus 1 would give you positive 1/2. And then you need to multiply a 2 out front plus c. So the 1/2 and the 2 are going to cancel. We get y equals u to the 1/2. That would be square root of u, which is this 3 plus x squared plus c. All right, that would be the general solution, but we have an initial condition. So we're going to plug this in and find the one particular solution that we're looking for. So we're going to plug in 1 for x and 14 for y. So if x is 1, that would just be 1 plus 3 would be 4. Square root of 4 is 2. And so that gives us that c is 12. So I'm going to recopy this line, but put in 12 for c. And so that is our one particular solution for this initial condition. All right, number 8, separating the variables. We're going to divide over the y, so that'll be 1 over y dy, then multiply over the dx, so x squared dx. So your antiderivative for 1 over y will be ln of y. Again, that only works for 1 over y. If you have 1 over y squared or 1 over y to the third, or like this one we did over here, 1 over y to the fourth, you have to write it with the negative exponent and then deal with doing that antiderivative. The only one that has this ln pattern is just 1 over y. And make sure you put the absolute value because that's going to be important here in a second too. And then this would be 1/3 x cubed plus c. And we're just going to find the general solution for this one because there is not an initial condition given. So we're going to get y by itself. To get rid of the ln, we're going to exponentiate both sides. So it's e to the power of all of that. That'll cancel out. So we get absolute value of y equals, it's e to the power of this whole thing. Now, when you multiply, that's when you add your exponents. So this is e to the 1/3 x cubed times e to the c. Again, when you multiply, that's when you add your exponents together. So it's e to the 1/3 x cubed times e to the power c. Now here's how you see this written. E is a number. It's just a value, 2.718 ... C is also just a number that's representing a constant. So this entire portion is just a value. So the way that you see it written is they'll put that out front just as one big constant. Again, if E is a number and C is a number, the whole thing is just one big number. So they'll put that out front just as like a coefficient for the constant. So it'll be C e to the power of all of this. And then when you get rid of the absolute value, you're going to put plus and minus. An absolute value is a distance from 0. And so like, for example, say you wanted to be 5 units away from 0. You could do that by going to +5 or -5. So when you have that absolute value, you're going to put a plus and minus. The other way you can think about that is from a graphing perspective. This would be an exponential function. And so if you think about having a horizontal asymptote, an exponential swoop could be up here, or if it's negative and you reflected it, it could be down here. So that's why you get a plus and a minus, because it could be either one of these. Again, it's a representation of an infinite number of solutions. All right, so for this one, we're going to divide over the y. So it will be 1 over y dy, multiply over the dx, and then antiderivative. So again, this is going to give us ln. This side will be x to the 4th plus c. And then to get rid of the ln, we're going to exponentiate. We're going to need a plus minus for the absolute value. And we put c out front. It will be c e to the power x to the 4th. All right, so again, e is a number, c is a number. We just write that out front as one big constant. So c e to the power x to the 4th. This is the same thing, except there is an initial condition. So we're going to get one particular solution for this. So divide over the y, multiply over the dx, antiderivative. So this is going to be ln of y equals 2/3 x cubed plus c. And now we're going to plug in the initial condition. Make sure that you plug in the initial condition right away. Don't do any solving. Plug this in. If there is one, plug it in like immediately. So we're going to plug in 0 for x, which is nice. That'll make that all go away. That'll just be c. Plug in 3 over here for y, and so that's ln of 3. The absolute value of 3 just is 3, so you can drop the absolute value at that point. Like once it's not a variable anymore, once it's just a value and you know that that value is positive, then you don't need the absolute value anymore. So we're going to recopy this line exactly except we're going to put ln of 3 in for our constant. So we know that that's the value of c. And then you need to get y by itself. So again, you're going to exponentiate both sides. It's e to the power of. E and ln will cancel out, so you'll just have a 3 out front. So 3e to the power 2/3 x cubed. I didn't put a plus and minus. Again, just like with the even roots that we did, like here, you don't put a plus and a minus, you make a decision, do I want the plus or do I want the minus? Because you're just finding one answer. This case, it was negative because our initial condition was negative. In this case, it's positive because our initial condition is positive. So the plus and minus is only for the general solution, like if you're leaving C in there. If you're finding one specific particular solution, then you make a decision if you want the plus or the minus.